Welcome back, class. Mrs. Matheson here. We are going to be doing Unit 6, Notes 3, and we're going to be talking about special right triangles. So we are going to know and apply properties of 45, 45, 90, and 30, 60, 90 triangles to solve problems and logically justify results. So we're going to talk first about what a 45, 45, 90 triangle is, and then we're going to talk about some rules for those. So here, number 1 says, use the Pythagorean theorem to find the sides of the square. Well, we know nothing about this. So this is actually a 45, 45, 90 triangle. If I draw in a diagonal here, that diagonal is now, remember our rules from quadrilaterals and specifically squares, that diagonal bisects or cuts in half the angles. And in a square, our angles are 90 degrees. So now we have 45-degree angles in these two sides. And we still have our 90-degree angle here. So if I just sketch that out quick here, you have 90, 45, 45, and these two sides are the same. Okay, so we're going to call that diagonal C. And so we're going to use C to help us solve about these sides of the square. So let's just start and call this side 2. Well, in a square, each side is 2, so that side's 2. So I'm going to use Pythagorean theorem to find my diagonal. All right, so I'm going to take 2 squared plus 2 squared equals c squared. 2 squared gives us 4 plus 4 equals c squared. So we get 8 equals c squared. Now I just want, oops, not 8 squared, 8 equals c squared. I just want the hypotenuse. So to get the hypotenuse, we're going to take the square root on both sides. Now we've broken down square roots before. We've done that in algebra. So we're going to break down this square root of 8. So if you think about it, some of us practice factor trees. Some of us looked for largest perfect squares. 8 is going to be the same thing as 4 times 2. So I know that the square root of 4 is a perfect square, and that's a 2. So I'm going to put a 2 on the outside, and this other 2 is not a perfect square root, so it stays underneath. So my hypotenuse is 2 square root of 2. Now, I just want you guys to watch this. I'm going to try it again. But now I'm going to change my side lengths. Just watch. You don't need to write this. I'm going to change it to 3. Again, I'm going to find the hypotenuse. This should say hypotenuse. Hypotenuse of the square. 3 squared plus 3 squared equals c squared. 3 squared gives us 9 and c squared. So we get 18 equals c squared. Again, we just want c, the hypotenuse. So we're going to take the square root on both sides. 18 is going to break into 9 times 2. 9 is a perfect square. Square root of 9 is 3, so that goes to the outside. This 2 is not a perfect square, so it stays underneath. All right, I'm doing this again, but I'm going to change the side length because I want you guys to be looking for a pattern. Let's change it to 6. All right, so we have our two sides. 6 squared plus 6 squared equals our hypotenuse squared. 6 squared is 36 plus another 36 equals c squared. So we get 72 equals c squared. Again, we're going to take the square root because we just want the hypotenuse. And 72, we're going to break that into, I'm going to just start writing over here, 36 times 2. 36 is a perfect square root, and that's 6, so that goes on the outside. 2 is not, so it stays underneath, and that's my c. I want you to take a look here at all of my solutions and see if you see a pattern. What if I changed my side lengths to b? All right, what do I think, based on what I saw previously, that I would have for my hypotenuse? Well, if you look here, I have a 2 on the outside, and 2 is my side length. I have a 3 on the outside, 3 was my side length. I have a 6 on the outside, 6 was my side length. So if b is my side length, I'm going to have b times the square root of 2, and that's going to equal my hypotenuse. Now if I want my side by itself, so b by itself, I need to get b by itself, I would do that using the same idea here. I have b squared root of 2 equals c. So I'm going to divide both sides by square root of 2 to get my b by itself. So my side is the hypotenuse divided by the square root of 2. So keep those two things in mind here as we go to our little chart. So now we're going to talk about the general form of a 45, 45, 90 triangle. The sides are congruent, and we're going to call those x. So if I'm given the legs to find the hypotenuse, remember our first problem, we take our side and we're going to multiply the leg by the square root of 2. And that's going to find my hypotenuse. So my hypotenuse is x square root of 2. Remember, if we were given the hypotenuse to find the leg, so I want to get x by itself, you divide the hypotenuse by square root of 2. Oops, I should put hypotenuse in there, huh? Hypotenuse by square root of 2. So if I'm given the legs, I multiply by square root of 2. If I'm given the hypotenuse and I want the legs, I divide by the square root of 2. Let's use that in this first problem here. We are looking for the legs and we are given the hypotenuse. So what does your rule say on this little box? We're given the hypotenuse. To find the legs, we're going to divide the hypotenuse by square root of 2. So we want x, and we're going to take the hypotenuse, which was 12, and we're going to divide it by the square root of 2. Remember, we can't divide by square roots, so we need to rationalize the denominator. This is bringing you back to some algebra. Multiply the top and the bottom by square root of 2. So we get 12 square root of 2 on top, because 12 is outside the square root, 2 is underneath, we don't multiply those. The bottom, we have 2 and 2 both underneath the square root, so we get square root of 4, which is going to simplify to 2, sorry. We do have some terms that can be simplified, the 12 and the 2, because they're both not under a square root. So our leg is going to be 6 times the square root of 2. Or if I asked you to approximate it to a decimal, you just take 6 times the square root of 2, and we're going to say x is approximately 8.5. And when you get to your practice, I'm actually going to ask you to do both of those. Give me it as an exact answer with the square root and as an approximate answer with your decimal. Let's take a look at B. B, we're given a leg and we're finding a hypotenuse. All right, so if we're given the leg and we're finding the hypotenuse, look back at your little chart. If given the legs to find the hypotenuse, we multiply the leg by square root of 2. So we're just going to take 4 and times it by the square root of 2. That's the exact answer. If I asked you for the approximate answer, you're going to take 4 times the square root of 2. And that is going to give you 5.7. So for your practice, I'm going to ask for both. All right, I want you guys to take a look at C. C, we're given the hypotenuse, and I ask you for the legs. I want you to come up with what is x equal and have that ready for us for tomorrow. Now, if you look on the back side, we're going to tackle 30, 60, 90 triangles, and those are going to have a few more rules. We're going to do those in class. So we'll see you guys then.